Hey guys, welcome back. I'm gonna talking about edge inside the Companand, inside the motors, flywheel, the coil unit. Okay, you see now the coil, copper coil unit. This is the cooling panel. The chilled water is going inside to the coil. The panel will be cool, so the air is pass through this panel, then the air is getting cooling. So this is the plier. This plier is push out the cool air into the room. So you see now the ducting inside, this ducting, the motor, the plier. This is the copper coil unit. This copper coil unit inside the tube. This tube inside the chill water going inside, then the whole panel will be very cool. The circulation, the return air is coming through this way, then fires and out the cool air into the room. Okay, this is the HU compartment. You can see now. This is the edge overall the compartment. Okay, this is the fresh air temper. The temper is based on the CO2 carbon dioxide. The temper will be automatically open and close. Okay, so this is the return ducting from the room. From the building, return air is coming into the HU. There is one more filter. Just now I show you the video, the filter how to open this video. If you have to see the video first, then you can understand. Okay, so this is the HU is full figure. Okay, this is the supply ducting and this.
Air handling units, which usually have the acronym of AHU, are found in medium to large commercial and industrial buildings. They are usually located in the basement, on the roof, or on the floors of a building, and many large buildings will likely have a mixture of all of these. AHUs will serve a specified area or zone within a building, such as the east side or office areas from floors 1 to 10, or perhaps a single purpose such as just the building's toilets. Therefore, it's very common to find multiple AHUs around a building. Some buildings, particularly old high-rise buildings, will have just one large AHU, which is usually located on the roof. These will supply the entire building. They might not have a return duct. Some older designs rely on the air just simply leaking out of the building. But this design is not so common anymore in new buildings because it's very inefficient. Now it's most common to have multiple smaller AHUs supplying different zones to give better control and higher quality space conditioning. Buildings are now also much more airtight, so we need to have a return duct to regulate the pressure inside the building. So what is the purpose of an air handling unit? Air handling units condition and distribute air within a building. They take fresh ambient air from outside, then clean this, heat it or cool it, maybe humidify it or dehumidify it, and then they'll force it through some ductwork around to the designated areas within the building. Most units will have an additional duct run to then pull this dirty used air out from the rooms back to the AHU, where a fan will discharge this back into the atmosphere. Some of this return air might be recirculated back into the fresh air supply to save energy. We'll have a look at that later in this video. Otherwise, where that isn't possible, thermal energy can be extracted and fed into the fresh air supply intake to also save energy. Again, we'll look at that in much more detail later in this video. Let's have a look at a simple, typical AHU design, and then we'll look at some more advanced ones. In this very basic model, we have two AHU housings for flow and return air. At the very front, on the inlet and the outlet of each housing, we have a grille to prevent objects and wildlife from entering into the mechanical components inside the AHU. Here's a photo of an AHU intake that would have sucked in a whole bunch of trash if the grille wasn't there, so that's why it's important to have this installed. At the inlet of the fresh air housing and the discharge of the return air housing, we have some dampers. The dampers are multiple sheets of metal which can rotate. They can close to prevent air from entering or exiting the AHU. They can open fully to fully allow air in or out. And they can also vary their position somewhere in between to restrict the amount of air which can enter or exit. I'll also show you some examples here of real-world dampers in AHUs. The one on the left has the motorized controller visible, which changes the position of the dampers. After the dampers, we'll have some filters. These are there to try and catch all the dirt and the dust, etc. from entering the AHU and also the building. If we don't have these filters, the dust is going to build up inside the ductwork and within the mechanical equipment. It's also going to enter the building and be breathed in by the occupants, as well as make the building dirty. So we want to remove as much of this as possible. Across each of the filter banks we'll have a pressure sensor. This will measure how dirty the filters are and warn the engineers when it's time to replace the filters. As the filters pick up dirt, the amount of air that can flow through them is restricted, and this causes a pressure drop. Typically, we'll have some panel filters or pre-filters to catch the largest dust particles. Then we'll have some bag filters to catch the smaller dust particles.